I'm like 6 years experience.
This meeting is being recorded.
I'm being a 6 years trainer. I'm being 6 years experienced with the data domain now. So today I'll be just walking you through what are the basic requisites to be a data engineer and the roadmap to it, and what and all skills like we have to learn, and a basic overview of what is Hadoop, and why we have come out of Hadoop now, and what's the current architecture that we wanted to take in when we wanted to do a data analysis. Uh, so we'll make it an interactive session. So Samita, what is your understanding about like this data domain?
If I tell you now, I have zero knowledge about IT. I am not from IT background.
Okay.
So, yes, I am from teaching background.
Mm-mm.
Uh, so I am just totally new to this.
Okay.
So,
Okay.
yes.
Then it should be fine. Yeah. So when we say big data, so it is not the data is big. So currently, everything is a data is what they say. Like from each and everything, we collect data. When you log into a browser, it is like I can give you a real-time example. When you go search some things in the internet, you can see the ads are getting popped up based on the things that you have searched. You can see that a suggestion from Flipkart or a suggestion from Amazon is coming on your browser or such things on which you have searched somewhere else. Even in Google, if you have searched like phone, like iPhone, if you have searched, then you can see the ads getting popped up from Amazon or Flipkart website for that sale or with a discounted price. So they have collected your data somehow, like via the browser cookies or so. So they are knowing that you are having a requirement for this iPhone. So via this data, they are applying a marketing strategy to sell you that phone. So first time when you see that ad, you can see it in one price, and the next time when you see that ad, you can see that the price have been slashed by some amount. So that is how a data analysis work, and that is why big data and data has boomed up to this level now. Because before 5 or 10 years, it was like only Java, C, C++, those things. But nowadays it's like everybody speaks about data engineering, data engineer, big data scientist, everything. It's like that. It's like a boon. Because on the other hand, it has given a lot of revenue to all the companies. So with data they are able to do anything that they want. So that is why this technology has boomed up like this. So at the end of this session, I'll give you a roadmap to what and all you have to learn to become a very good data engineer. And to be in this salary perspective, data engineering is a very good role that where you can get uh, unexpected salaries for a very less experience. So we will go through. We will start. I'll share my screen. We will go through a document. Sorry. You're able to see my screen, Samita? Samita, am I audible?
Yes.
You're able to see this Word document, right?
Yes. Yes.
Okay. So as I said, data. So I don't want to explain what is data, those things and all. That's a very basic thing that we can go through in our one by one session. It's a demo session, right? So I just wanted to explain the basic and main things, actually, not even the basic things, main things. So previously, when we say big data, we will have data collected anywhere and kept it in a database. It is a common thing. Wherever you collect data, you keep it somewhere. So usually we keep everything in a database. Previously, we have been using like now also we use the Hadoop processing for this big data. It is like batch of data that we get. It is not like one data or two data. Like millions and trillions of data that we get. So we use the Hadoop structure to process those data actually. So we have been using this for around 10 years actually. But now we are not using it. But let me explain, because the basic concept lies the same way. It is also running behind the map reduce algorithm. So when you say Hadoop, it is a distributed processing. It is like when you consider you are having like 1 lakh record, it is like 10,000 records will be splitted across different nodes, and from there you will be utilizing it. And when you say HDFS, it is a storage location. So it is a file storage, Hadoop file storage, where you have actually saved your data. So only when you store your data in HDFS, you will be able to access your data via the Hadoop. This yarn is like the job scheduler and a manager. This Hadoop common is like, it is basically a Java program. It runs behind this Java thing. So this MapReduce is an algorithm that will actually run like this. So consider, I said you to consider considering 1 lakh records. So via this HDFS split option, you can see it has been splitted into 30, 30, 30 records. And this splitting is based on how many worker nodes you have around the data node. So here data node is the basic master node who gives the data to somebody. And the data node is the data node is the actual worker node, like whatever program you write that will execute for that particular data set, and it will give you an output. So when you start an Hadoop program, so this split is what will happen. It is the first level because it runs behind the MapReduce algorithm, which is a Java based program. So here a splitting would happen, and initially the key value pair should be there. So it will be mapped to a particular key. Then a shuffle and sort will happen. It will arrange in one particular order. It is by key, like from consider it will be arranging from 1 to 10. Then it will be executing done program one by one. Consider if you wanted to, I can give a real time example, like consider you wanted to change some value for a particular ID. Consider an employee information. You wanted to change for an employee name Shanti. You wanted to change her address. So, but when you go into an employee database, you can find multiple Shanti there. So you wanted to give a specific value there. So based on that value, this reduce operation would happen. That is how it works. So this is the Hadoop operation. But currently, this Hadoop has been replaced completely by Spark. So previously, this Hadoop model was there, which was like a very slow process. It was like a batch processing actually. But but now we are having everything in a streaming way. Data is getting streamed directly from the sensors or whatever you see. Consider Facebook and Twitter never stops in the generation of data actually. So we go into the we go into the streaming. We have to process the streaming data also. It is not like once you get a dump, you process it, then store it somewhere. It is not like that. So it is like continuously you'll be getting data from some source and you should be able to process it. But that feature is not supported by Hadoop. Hadoop can only do a batch processing, where Spark can do a real-time processing. So that is why we switched from Hadoop to Spark. So we have different characteristics of Spark actually. In Spark architecture, you can see, I will show you the Spark architecture actually. It is an open source one. It's an analytics engine. Everything it will be able to do. So similarly, so similar to Hadoop structure only, it also has a driver program, and here also it's like a name node, worker node, same concept. But here you have a cluster manager, but here everything will be split into a task, and the worker node will be able to do the task that you give. But the but this would be like very fast. The execution would be very fast, and it can do whatever it wanted to do. And previously, when we were speaking about Hadoop, it was only supporting Java. But here in Spark, it will be supporting SQL, Spark, Scala, everything. So here you, sorry. Here you can see the streaming, right? This is what I was speaking about. The streaming data, for the actual streaming only, we came into this. That is the main thing actually. And in addition to that, we are having the graphics, the machine learning library, all those things. Because you can go one level ahead and you can do some data science activities also. It is having many libraries. What to like, you can build a model actually with the thing. So recently they predicted the who would who would actually win the elections recently. So that was all about a data analysis. So that was all about how they built a sample model. After that, they put the data into the actual model. So they were able to find who can win, the probability of winning. Till the election winning process, this data would help. That is how it is. So that, and Spark can also work with Spark. You can directly connect everything to a cloud. So when you say cloud, it is like Azure or AWS, any cloud. So previously we were having everything in on-premise cluster. So previously we were having everything in on-premise cluster. We will be having a hardware cluster. Like we have a UPS in our home, we will be having the data servers at some part of the world, and there your data would go and save. Similarly, there is a server existing in cloud also, but here everything is like, you should only pay like for what you save. So that is how a cloud works. And with the Hadoop, the connectivity to the cloud was not possible. But with Spark, the connection to the cloud is possible. So only we are switching to Spark from Hadoop. That is the major thing, and it is having a very good interactive processing. But this latency is slow. Why? Because what when you hear this term latency, it is like the speed with which the data can be taken, and data can be read and write from one particular cluster. That is what a latency is. So Spark has a low latency because everything, it is not in the premise on premise cluster. But Hadoop has a high latency because it is a setup. You set when you go to a computer lab, you could see one system is the name node, and the other one's a data node that you will be able to see. So that is a basic difference. And as I said, with the Hadoop, we are using a map reduce algorithm. Uh, but with Spark, we are processing real-time data, like whatever data we get in the current stream, it should be able to process. And Spark is actually a costlier option compared to a Hadoop, because we have to give it a lot of memory. I will show you, like after some time, I will show you how a Spark cluster is configured. So it takes a lot of memory. So it is it's comparatively a costlier option. And after that, uh, it doesn't stop with the data processing alone. It gives you a lot of options to show you the representing the same data in pictorial manner, or and some other ways also. And DAG is a very important concept of Spark. It is directed acyclic graph. uh, so when you start running a Hadoop program, when you just start it, just when you hit the run button, it will start running in the background. It will be consuming a lot of memory. But when you type in a Spark code and you give it a start, it won't. When you just type it in the editor, so no memory would be considered. Only when you trigger an action, it will be starting to run. These actions, these things, and all can be covered later because it's all very deep topics. Just wanted to give an overview. Actually, this would be a little technical for you, but I just wanted to show you this a basic difference. Because wherever you go learn big data, everybody will be concentrating on Hadoop only. But Hadoop is not into current market. Actually, nobody uses Hadoop. Everybody uses Spark. So, any questions till here, Smita?
No.
No, everything is clear for you.
Yes, yes.
Okay, fine. So we all have to concentrate on learning Spark more. It has very detailed operations. It has many functions inside it. So we have to concentrate on that only. So when you say DAG, it is a directed acyclic graph. So I said right. I can show it in this piece of code. See, this is also a code, sample code. Here, I'm just trying to find the number of words in a text file. So this is the place where you have to mention the path, and this is the file permissions that you give. So here, data file.read, it will be reading all the entire file and storing it as a data. Only when we trigger this line, data.split, because split is an action here, the entire program would start running. For the entire program, the memory would get allocated and it would start running in the background. Otherwise, it won't run. So that is how a word count program works. And you can also see if you wanted to write the same word count program in Hadoop, it would take you around 15 or 16 lines to write that. But when you use Python, it is very less. That is why people switch to Python now. I will also show you why we use Python, but later. So now when we are coming to DAG, so it is directed acyclic graph. It is actual scheduler. So here you can see how a Spark program actually works. It does have a driver program first. So it sets up Spark context, and it will actually, everything will be already on data frame in Spark. It will not be like a data block or data, nothing like that. Everything will be like a RDD and data frame. Even if you form a data frame, I know you are not aware of this data frame and RDD terms. I'm just saying here. I will explain it in further sessions. So when you read the file, everything will be formed as a RDD here. This driver program would request the worker nodes, like it will give the indication to the cluster manager to split up this work across the cluster. So how much worker node you have there, in each and every worker node, there will be an executor. And as a backup node, where we have in Hive, which we have in Hadoop, we also have a backup node here, and everything will be there in logs, so not an issue. Even if you lose some node, if some worker node stops working, then you should be able to retrieve your data. So before it actually gives the indication to the cluster manager. In the meantime, it also speaks to the Spark context, which we have already set here, to actually prepare this DAG scheduler and task scheduler. Here, the data would be like the work would be like splitted across the nodes. Here, the scheduling way would be like given to this DAG scheduler. So, as I said, only when an action is encountered, it will create the job. It is like jobs here. It is not like an activity. Each and every job will have a DAG prepared. We can also relevate it to, but getting a real-time example here actually to relate. How to say? Okay, we'll come to it later. So we can see why we opt Python when we have many other programming languages. Previously, we would have heard like Java, C, C++, Perl. We use Ruby, all those things. But now Python is like ruling the entire data science world. Because we are having many supporting libraries for it, considering this NumPy, Pandas, and Matplotlib. So when you just start with the data processing, you always go with Pandas, because in Pandas you'll be having a lot of functions, inbuilt functions to the process data, where you have to write a lot of code in Hadoop, but in just Pandas, it will be like just a one-liner to process the data. So that is why we switched to Python, and the syntax is very easy here. Python is very easy to learn, and it is like a in a very readable manner. If you're going for split option, split will split it, split the data. It is not like some other name you give it for some function. It is very understandable, very readable. So it is NumPy, Pandas, and Matplotlib. Uh, And we have this SkyPy and scikit-learn also. It is a little advanced. Uh, this is on this manual part that I wanted to say, like this physical part of data. So now I will share you some views in the industry perspective, how things are. So okay, consider a truck domain or consider an airline domain actually. Consider an airline domain. Um, when you go search for a ticket from Delhi to Goa, when you go to Air India website and you go search for a ticket for Delhi to Goa, you would see some price. It will be like when you observe it actually, when you regularly search, you can know that it will be high on it will be high on a weekend, it will be high on a national holiday, and if you're just booking it 1 day or 2 day before, you could see the prices are very high. But you can see, yeah,
Yeah.
yeah, Smita. So it will be very high. But if if you have searched once and the next time if you search, it will be too high, comparatively very high. That is how it is, because they have already captured your data. But what I said, right? Like we are able to see it high on a public holiday and this weekends and all, because they have an algorithm already written in the background to make it high for all the days. They call it as a pricing thing, pricing algorithm. They say so. This is all based on a data analysis only. So what we did as a team, we I was once working in that project. So what did as a team is like we were collecting the data from each and every uh, person who hit that website. We were collecting the data from the server, and we were seeing on what and all weekdays also we are getting the hit high, and other weekdays, because we always have it high on the weekends and the national holiday days. But we also wanted to increase the revenue of that particular airline, uh, so that the any two of the weekdays at least we can find where the maximum hit happens. So we were collecting the data, so that airline was approaching us and they were giving us data, and we were processing it. So when you go for a data processing, it will be like a cleanup. After that, you will be putting it in your own format. They will give you in some other format, and you have to put it in a feasible format in which you can actually manipulate it. After that, you will be performing the functions, what and all you have. Uh, like you will be applying all the logics. There you will be applying some machine learning things also. So we have applied, and we have also found out we get it hit high on Thursday and Tuesday also. So with that, they have actually raised their revenue. Actually, their profit got raised. So that is how a basic data engineering works. So I said this example because when a client gives you a data, he doesn't always give you in a CSV format or a Excel sheet. It is not like that. He is giving you tons and tons of data. So he would always prefer giving it in a Parquet or Avro format usually. And when you go to interview also, you will be obviously getting this question, which is the best format to you get the data. So usually they prefer Parquet data because it is a airline, so it has the customer data also. They cannot give you straight away in a readable format because they have encrypted some data also, like the customer information. As per rules, they are not about to reveal all those stuff. They should take care, and they will be giving you in separate format. We can You can see we have different properties for all these data. For some it fits, some it doesn't fit. Like when you take a normal sales data, the CSV format would be easy for you, but when you take consider customer data, Parquet would be the best format. So each and everything, when you have some key value pairs, JSON would be the best format. So something like that. Based on that, the actual data format, like file format, is supported. So here we have the schema evolution. Schema evolution is one property of the file. When you just put it in the Python code, it will be able to find the schema of that particular data. So So this is the roadmap. So before this, I will show you an live example, not live did a notebook. So previously, you can see you have at least heard like people will be using an IDE, integrated development environment like NetBeans or whatever IDEs that they use. They will just type in the code. They will just run locally, right? So here, okay, it is off now. Fine. Uh, but here nowadays everything is like a notebook. So when it's a Databricks notebooks, it is given by Microsoft Azure. So here in this notebook, you can see it supports different languages like Python, SQL, Scala, R, everything. So it is not like it supports only one language. So whatever type, when you keep it Python here and whatever type code you type in here, it will be directly taken into a Python code. It will be considered everything, whatever you type, it will be inferring the direct thing like a Python code. So this Vega anonymization is a notebook that I have recently worked on. So it is also a client data actually. So here I'm just reading. I said everything is a Spark now, and now everything is like a PySpark. Python plus Spark is PySpark. So I import some functions from PySpark. So when I give a data frame is what the actual data is stored. So I'm just, you could see this line is just a read line, which is just reading the file from this particular location. So this format is delta and I'm giving the header options true because I wanted to see the column names also. So I set the schema inference, right? When you say this info schema as true, it will actually go take the schema of the data. Schema of the data in the sense, whatever column it has, and consider it has a roll number column. It will infer the schema of roll number column. So what type of data the entire column has? Okay, it has integer. Okay, it will be inferring as roll number integer, something like that. So here you can see. Here you can see that the column name is there and the type is there. It is of struct type. So inside struct, single struct, we are having such columns. So this was the activity. So what my client was asking is, you just read this data from this location. So it is in struct format. I want all other column separate, not in the struct, because with the struct format, it will be very difficult for you to process. So I want it in a different format, like everything as a single column. That was my requirement. And he also asked me to hash two columns. Hashing in the sense, you wanted to put some random number to the client information, because on going the like after processing also, I don't wanted to reveal for like this vehicle number is having this. I don't wanted to reveal that. So he gave me the activity with two requirements to split these columns as a separate columns from this struct and to anonymize, like to hash those two columns. That so this is how a actual industry requirement would be. I wanted to show you. That's why I took this example. So what we read right here, we read it as a Vega data frame. So when you display the Vega data frame here, you could see the data is coming this way, like the same format in which it is in the file. So here I'm just trying to split all the columns into a separate one. So I'm just putting data frame dot select column dot star, column of this entire struct, and this is a struct name dot star. So this is simple. It is like wanted to split a struct to a column. It is just taking this three letters column. It's a function. Call of function will give you the splitted columns from a particular struct. So that is how it works. So I have taken it that way. So here, previously you were able to see 13 more fields here. This data frame, you were able to see 13 fields. So here it is 185 fields. So you can see everything is like a column. that struct is now split into a column with just one function called column function. So now it has got splitted. So I had another requirement, right, to hash this particular columns. So fin and win numbers are the vehicle information. So fin is the another way to it. So I wanted to hash it. So here with column function, we'll take any particular column uh, from that data frame. And SHA2 is an algorithm to, it's a hashing algorithm. It will just anonymize it. So SHA2 I have used for this particular column, and for 256 bits, I have to encrypt it. So it is such a way we have to do it. So when you see the fin here, I will show you. Where is the fin here? Mm-hmm. In claim data, we are having the fin, so it should be in the first column. Yeah, you can see the fin and win here, right? It's vehicle information, the same value you will be having. So here I have used this SHA2 algorithm to anonymize these things, but I have not displayed it. If you display, you will be able to see it in anonymized format. So after that, I'm just writing all the output to the ADLS location in a Parquet format. I said like what format we are using. Parquet I have used, and I have written to this ADLS location. So ADLS is the storage location of Azure. So we say it that way only. So we have shared it that way. So when we go back to this, any doubts still here, Smita?
No.
Okay. So when you wanted to become a data engineer, okay, I can. These are the things that we have to concentrate on. Then going downwards and show that is much more clear. So data science one. Okay, here. Okay, I will just explain you here. So to become a data engineer, actually first you have to concentrate on learning the Python to the core, because as I said, it has a lot of functions which will enable you to dig in the actual functions and other things, like how to actually process the data and the libraries to it, everything. So second, you have to understand the relational databases. So always when you come to data, you save it somewhere. And obviously the output will be stored to some table in whatever projects or real-time projects you work in. So you have to understand how a relational database work, what are the basic functions that a database goes in, those things you have to learn. And you have to learn Linux and cloud computing. When you say Linux, it will be like an open source thing. See, everything was open source previously. Like even if you are using a Windows now, internally it will be doing an open source operation. So Linux is a basic thing, but you don't have to learn it to the core level. But basic understanding of what Linux is, what this command is important. And what a cloud, how a cloud computing work, because everything, nobody uses an on-premise cluster now, because the on-premise cluster is very costly, and the latency is also very low. So everybody uses the cloud now. Whenever you go apply for a job also, they will say whether you know Azure or AWS. They will ask you this also. They will not admit you once you have said, so I know with just data concepts. They will also ask you for cloud things. So you should be much aware of the concepts, and how a ADF works, how a pipeline works, like how you can actually store the data in blob, all those stuffs you should be aware. So next step is a NoSQL database. NoSQL databases is where you can store any type of data. So when I say this Hadoop, when I say the streaming data, this streaming data will not be in any particular format. Some may stream images also. So in any particular way you get data, you should be able to save it somewhere and you should be able to process it. Examples like MongoDB and other things would work. So basic understanding, it's not like you have to learn everything, do a certification on NoSQL database. No, that's not required. It is like you have to have a grip on NoSQL databases. That is one, this Hadoop ecosystem. Though Hadoop is not in use now, still it was the base of everything. The same map reduce concept, this mapping and reducing concept is what is used in Spark also. But it is not used in the same way. But the conceptual wise, whatever concepts were there in the Hadoop are used now also. So you should be aware about that also. And this data warehousing, it is a very very important concept. When you say data warehouse, you take go save data somewhere and you analyze that same data in multiple formats. Uh, when you take this employee related information and all, always we use it that way. How much leaves that employee take? How much uh, that the daily logging time of an employee? How much permissions he has availed for this month? Those things and those analysis is all happening in SAP based system also based on this concepts only. So data warehousing concepts are very important. So like to the end of the slide, it's a data visualization. So you take a data, perform all the operations that you know, or do all the manipulations of the data. You have to present it in a very easy way, like easy understandable way. It is not like you type in 1,000 lines of code, you show to somebody, they'll not understand. So you have to show that in a very neat and easy way to understand. So for that, we are having many data visualization tool like Tableau, and everything will be a dashboard end of the day when they do an analysis. So for that, we have gain a basic knowledge on data visualization also. And this Apache Spark, which we were discussing in deep. This is actually the base of everything. Without Spark, you will not be able to process any data, streaming data and all. So this is when till here it should be fine. Actually, after this, the streaming events, Kafka, that and all is like optional. That is at a secondary level. Airflow is a secondary level. Till here, if you're able to learn in Excel, then it should be very sure that you'll obviously go into a job with a very very good package. So in each and every concept that we discuss, we can also discuss the interview questions and how they would ask and all. And seriously, to get into IT, you don't require any previous IT experience. That would be your question in mind, like how I would go and go into the industry and survive with other IT people. No, it is possible. I have seen in recent times like a BSc graduate as performing very good than a BE candidate. So that is all possible. It's just how you upskill you and remain updated in the technology. It's like you have to do a continuous learning always. You should be open to learn. If you don't know something, you should be open to ask. First level you can search. If you don't understand the concept, you ask to someone. So it should always work. So that is how a data engineering is. I have given the basics like what and all I know. So
Yeah.
going forward, we can do it in a better way.
Okay.
Yeah.
So how many months course is this? It's showing it's like in the last slide it shows from January to December. How
Ah,
so? Oh,
that is just a so what to say. That is just a roadmap. It is not that
yeah,
course.
that's what. Yeah. That's what I'm thinking. So how long it is?
No, I think we'll be covering it in 50 classes. Yeah.
50 classes. Okay.
Mm-hmm. 50 classes. We
No, no.
will have like 2 or 3 classes. For the in-depth topic, we will have 2 or 3 classes. We will have some assignments also daily. So we can check that at end of the day every day. We can make it industry oriented. So your basic this is to get a job, right?
Yes.
So we will focus on that way, and we will focus on very good package also. It's not like you enter in a very small package. Industry currently a decision is going on in the industry, but still there is a very big scope for data engineering, so it should be possible. I know that today also you didn't get many terms because it's a first class and you will not get the terms. I just wanted to
Yes.
demo this and all is the content, because each and
Yeah.
everything we
At
have to
least
go
I
in
learn.
depth.
Yeah, what I have to learn for this. These
Yeah, yeah,
things you
yeah.
show me. Yes.
Mm-mm-mm. Python, you have to concentrate a lot when you start. So post that we can. So it is not about coding actually completely. So previously, when we want to become a Java developer or so, right, it will be like full of coding. It's about thinking here when you come to data engineering. How you think, how you are able to solve those things. Sometimes you just get an file where extra comma would be there. The entire file would show an error. You'll be like completely blank. You will not be knowing what to do. So in that case and all, it will be like very hectic. So there will be very many real time problems also. Not it's not like just coding. You get output. It also involves coding, but it's not completely coding as a Java developer or a .NET developer does. It is about thinking also different dimensions. All those things are involved. Yeah. Any other questions, Amita? You have?
No, Nivedita, thank you.
Okay.
Yeah.
We can end this
Okay.
session or yeah, Samita.
You say, can you send this recording to me?
I think he will be able to share. I am not having
Okay.
access. Yeah,
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 he'll
that's
share.
fine. That's fine. I will ask him. Okay. Yes.
Okay, okay, sure.
Thank you.
Thank you, Samita.
Bye. Bye.
Bye. Can we end this session, right?